Question 12f, we've got the region bounded by the curve C, the y-axis and the lines y equals ya, which we found to be -2 plus 2 square root of 5, and y equals yb, which we've found to be y is equal to -4, and that's rotated 360 degrees about the y-axis to form a solid of revolution, and we need to find the volume of the solid formed. Okay, so up here I have written out the formula for the solid of revolution. So we're taking the integral with respect to y as we're going about the y-axis. So therefore we need an expression for x in terms of y to put that into the integral. And on the left side of the screen, I've got a diagram of the situation here. So I've shaded in the area that is bounded by y equals ya, y equals yb, and the y-axis. And we're going to rotate that 360 degrees about the y-axis. So I'll bring up a short animation of what this situation looks like. Even though it's not essential, it can help with just sort of understanding and visualizing these types of questions. Okay, so we're going to just rotate that part, shaded part in blue, about the y-axis, and then we can see the solid that we've formed. Okay, so that's what the solid is going to look like in this question. So there's just a few different viewpoints of it, and we are going to find the volume of that solid there. And now we just want to find x in terms of y, and then we can put it into the formula here for the volume of a solid of revolution. So I'm just going to write the curve C like this, so 4x squared minus 24x plus y squared plus 4y plus 20 is equal to 0. So now I've just got a quadratic in terms of x squared. So of this form here, plus c equals 0. So as you can see, this part here, the y squared plus 4y plus 20, that's just the c part in that equation there. So now we can just use the quadratic formula. We're going to get x is equal to negative b. It'll be positive 24 and then plus or minus. And I'll sort out this plus or minus a bit later on. So we'll just leave it there for now, and then we're going to have under the square root negative 24 squared, and then minus 4ac, so 4 times 4 times y squared plus 4y plus 20. And all of that divided by 8, 2 times 4, 2a there. Okay, and then x, so just simplifying this a bit here, going to be 24 plus minus, and then we'll just expand some of those brackets out. I'm going to get 576 minus 16y squared minus 64y, and then minus 320, and all of that divided by 8. And now I'm going to take away the plus sign. I'm going to be left with x equal to 24 minus, and I'll explain why in just a moment. And then under the square root, we'll simplify it. So we're going to end up with 576 minus 320. That's 256. And then we're going to have the minus 64y minus 16y squared. And all of that is over 8. Okay, so we took the minus part because it correlates to the left part of the curve of the ellipse there. So if I kind of fill in the rest down there in red, the left part of the curve would be that x is 24 minus all that stuff under the square root and then divided by 8. And if I do it in, say green, the right part would be the positive. And obviously we're rotating this part from A to B. So that correlates to the left part of the ellipse. So that's why we took the negative. Okay, so now that we've got that expression for x, we can set up our integral. So the limits. So YB was -4, so this part was -4, and then at the top here, it was -2 plus 2 root 5. So we're going to get -2 plus 2 root 5. And I'll take the pi out front because that is just a constant. And then we'll put in our expression for x. So I'll use brackets here. It's going to be all this stuff, 24 minus square root of 256 minus 64y minus 16y squared, all divided by 8. And then that whole thing is squared, so don't forget to square it. And we take that integral with respect to y. So don't try and solve this without a calculator. In paper 2, remember we can always use the calculator. So I'll bring the calculator up now. Okay, so there it is entered into the calculator. I just entered it already to save a bit of time. And then we're taking the integral with respect to y, and we'll enter that in. And then we get 29.708 and so on. So we can write that down. So this is equal to 29.708, etc. And therefore, to three significant figures, we can say the volume is equal to 29.7. Generally, you don't need the units, but it's going to be units cubed, whatever these units are. Okay, so that finishes off question 12f and finding the the volume of the solid of revolution of that curve C there, where we had those restrictions bounded by the y-axis, and y is ya and y is y